Back to this. That board there is the main board of the refrigerator, but where is it actually on the wiring diagram? Where all the wires and everything are? Where's the control board? ¿Dónde está el control? El maestro.
Control maestro chiquitico ese que está dentro. La memoria, la que usted señaló que es memoria chiquitico.
Esto?
That's the refrigeration control board, no?
That is, this here is that. That box is that. Now, one of the confusing things about a control board is what's going on in here. It's just an empty box. You're not even seeing the relays that they're showing you here. So it's hard to understand, well, what's going on? But if you look at the diagram, first of all, look at everything on that refrigerator connects to that board. That's like your brain. Your hands, your eyes, your heart, everything is controlled by your brain. Everything in the refrigerator is either controlled by the control board or used to give the control board information. Like, what is the temperature? What is there water or anything else? The control board is doing everything. Now, one thing you want to notice is look at the very, very top of the board. What do you see at the top of the board here?
DC side and AC side.
So half of this board, everything on this side of the board is DC voltage. Okay, that's usually our sensors. How many sensors do we have on this whole refrigerator? Look, the whole diagram. How many sensors do we have? This is a sensor, right? It says sensor.
5 sensors?
5 sensors.
No, 6. Yeah. 6.
6? Okay, well, let's name them. The freezer evaporator. So this is a bottom mount refrigerator. So the freezer's in the bottom. And on the evaporator is a sensor. So we're going to talk about what they do in a minute. The freezer sensor. So we have one actually on the evaporator tubing. But then we have another one just in the freezer. Okay? What about the fresh food sensor? That's in the refrigerator compartment, right? And then we got the tray sensor. Now, the tray sensor is usually the, let me see real quick. That might be the ice maker. The ice maker tray. This is called a flex tray ice maker. Flex tray is like back in the old days before we had ice makers. We had this plastic tray. We put water, and then we turn it and we flex it to get the ice out. Well, the machine has a plastic tray, and it fills up with water. Once it turns to ice, there's a sensor on the bottom of that tray, and I'll show it to you. And then the tray turns, but then part of it gets hit by plastic. So this is turning, but this one is not. And it twists the tray, and the ice fall out. Flex tray. Okay? So there's 4. You guys said there was 5 or 6. Where are the other ones?
2 on the bottom.
2 on the bottom, where?
It's a light switch. Light switch.
That's the right light switch and the left light switch, right?
Yeah.
Is that the only light switch that you see?
No, we have two more right here on the right side.
The light switch door and right. LH is left half and RH is right half. Now guess what? Oh, these 2 switches and those 2 switches are the same switches. What does that mean? This one says right half light switch, right half light switch. Left half light switch, left half light switch. Yeah, we have one on each door, but why are they showing 4? Why are they showing 4? There's only 2 switches. I'll show you, when we go to the refrigerator, I'll show you those switches. But why show 4 when there's only 2? Keep touching the screen and messing it up. But DC side, AC side. On that switch, you're going to find 4 wires. 2 cables, DC volts. 2 cable AC volts. Why? Why have all different voltages? Can't you just have one switch connected to the board and the board knows, hey, door's open, turn on the light. Door's closed, turn the light off. Microwave. You open up the door of the microwave, the switch goes to the board, and then the board turns on the light. So why have low voltage and high voltage on there? Well, the low voltage is probably part of what we call the logic. And what I mean by that is like, you know, like what happens if you leave a refrigerator door open too long nowadays? It starts beeping. Well, that's probably controlled off of the low voltage side, the DC volt side, is when the control says, hey, the door is open. La puerta está abierto. But this one here, look, let me see if I can draw on it. Look at this circuit here. When I come here, I go through the switch, come out, go through the switch, come out, and I go to, what is that? How about I make it bigger for you guys because you're all blind.
The auger motor?
Yeah. What's an auger motor?
Timer motor?
Nope. The auger motor is the motor that pushes the ice out the door. When you put your cup, the motor turns and has a screw we call an auger. And as it turns, it pushes the ice out the door. So this one controls the motor. This is not the one that is telling the door, beep, 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 close the door. But if you open the door, no ice. You can't get ice. So even though the dispenser's on the left-hand side, I open the door on the right-hand side, the dispenser won't. Okay? But this one here is the communication. Now, did you guys see something right there? What is that? What is a thermistor?
Thermostat for a...
Not a thermostat. What is a thermistor? It's a sensor. So there are 5 sensors. 4 of them are in the machine, and we're going to find all 4 of them. Okay? We're not going to be able to get to the one in the freezer, but I'll tell you where that one is. Okay? But 4 of them are throughout the refrigerator. Okay? And then this 5th one is actually mounted. Where did I put the control here? It's actually mounted right on the board. And that would be between J8 and J5. And if I look over here, I look for J8 and J5. And I don't see it. On the bottom? Or J5, I don't see J8.
Yeah, J8 is not shown.
But that sensor
Yeah, it's in the middle.
is somewhere down there. It's somewhere on this board here. So in this area of the board here, there's a thermistor or sensor on the board. Why do they have a sensor on the control board? What's it sensing? That the board is hot? No. It's used to control like heat and humidity. You know the mullion strip in between the 2 doors. What's the mullion strip? I just talked about that in one of my videos. That's to keep the refrigerator from sweating when you close the door around the gasket. So that this one here is a sensor telling the board. What if the condenser fan isn't working? Is it going to run hot down in that area? And this would know it. So the thermistor, I don't know all the purposes of the thermistor on the board, but there is a thermistor on the board. I don't think I've ever changed the board when that thermistor fails. Okay? And some refrigerators, they don't put it on the board. They put it at the very, very top of the refrigerator. On the top of the fridge, there's a cover that covers the hinges, and the sensor's up in there. But not on this one. Okay? So look, you say plus 5 volts. So you're only going to have about 5 to 12 volts on all the DC circuits. Look at that. Everything is 5 or 12 volts. All right. Now, if they're saying plus 5, which one is this really? 7, 8, 9, 10. What is that plus 5 telling you right there? What number is that plus 5 connected to? If you just looked at it, what would it connect to? 7? If I go like this, which one am I going to? 8. Okay. What about this one? 10. Next one? 12. So 7, 9, and 10 are the negative 5 volts. So in other words, that's plus and minus, like a battery. Negative and positive. Okay? So when you put your meter on there, if you're using a digital meter, it doesn't matter because it'll say 5 volts or negative 5 volts if you put it backwards. But an analog meter, the needle will go like this if you put it one way. If you put it the wrong way, the needle will try to go backwards and can't go. So it's important on an analog meter you know which one's plus and which one's minus. So they're telling you all the pluses. How about this one, 3 and 4? What if I wanted to check the 12 volts DC? What two numbers would I check the 12 volts DC on? Why 1?
That's your ground.
Okay, so from 4 to 1, that's my 12 volt. What about my 5 volt?
3 and 1.
3 and 1. 3 and 1, 5 volt. Okay, well, what's number 2?
Communication.
Communication. So that usually goes to another controller, another board, or maybe even a fan motor, and it's using that to sense something, communicate back and forth between the two controls. All right, so that is the main control board, but I told you this refrigerator had 2 boards on it. What is this board?
Inverter board.
Inverter board. What's an inverter board? It changes AC to DC, but it also controls the frequency. And that's how fast the compressor runs. Whether the compressor runs fast or slow is controlled by this board, which is controlled by this board. This board is telling this board, hey, run at high speed or run at slow speed. So if you just plug the refrigerator in, is it warm or cold? When you first plug it in, it's warm. So the compressor is going to run fast. But if you set it to 36 degrees in the refrigerator and it's 40 degrees, the compressor is going to slow down so that we stop right at 36, that we don't like go super fast and then stop. It's going to go real fast and then slow down the last little bit for accurate temperature. Okay? Yes. So if you look at this, this is what connects to your compressor. There's no relay or overload connected to this at all. Now, how does this connect to the main board? We have 2 plugs that go on that board. Okay? This plug here is going to plug into here and here. Okay? And then this plug here is going to plug there. Now, where is this board on the machine? Where would you find it in this diagram? No, it's on the screen right now. This goes to what? The compressor. So where is it in the diagram?
Top right.
Where?
The control signal?
Top right here?
No, the left side.
Here? This? What?
The control signal, that one on the bottom.
The control signal. I don't know.
Power, no?
Which one are you saying is control signal? This one here?
Yeah.
Okay, this is red and black wire. We look at this plug, what color are these wires? Red and black. This piece right here in my hand is what I just circled. That's this plug right here. Red and black. Okay? What about that one? That is
Oh, it's not.
this plug. What color? Black and light blue. In this case, it's white and light blue. Okay? On the Frigidaire inverter, this has 120 volts all the time, even if you turn the refrigerator off. Why? Because we follow this black and light blue. Black goes here and goes to line 1, and light blue goes here and goes to neutral. This goes right there. There are no switches or anything to this one plug. Why is that important? Why is it important that this has power all the time? It's not for the operation of the machine. It's for you to know. Why is it important for you to know this has power all the time?
Oh, to not be, not touch it. No, it's live.
Well, to know it's live, but I mean, when you work on a machine, you should unplug it anyways. But if I'm going to check a refrigerator, and this refrigerator, the compressor is not working, where do I begin testing?
Oh,
Right
oh,
there.
it's faster.
Okay, but power where? In the wall? I said the compressor is not working. So let's say it's lighting up. Fans are running. We have fans over here. I can't see it on this diagram. But your fan in the freezer, your fan in the compressor, they're all working. And the only thing that's not working is your compressor. Okay, so where do you begin testing on this?
Cables for light blue and black.
Okay, so the first thing we want to know is if we got 120 volts here. That's this plug. Now, after I'm done with the lecture, I want to put this boards back in the machine. Let's make this test. Okay, but what about this plug here? The control signal. This don't have my erase button on here, so I have to do this to get rid of all my lines. That's crazy.
You add the race, you click on tools.
This thing, I remember I had it set up and then it reverted to the newer version and really screwed up everything. So I just hate this new version. I got this software on my own computer. I'm going to bring my own computer so I can do my own presentations on here. So we got a compressor here, right? What does that say right there?
Pressure control signal.
Okay, but let's look at this diagram a little bit more for a second. Let me just see something.
And it has the same cables, red and black.
Yeah, I just wanted to see, because sometimes they show two compressors. I know the GE diagram does too. So that red and black, this 1 and 2, this part right here, not this box. This box is this board, okay? But that 1 and 2 is that plug right there. Those two wires right there. Notice that the two wires aren't connected to anything. Why did they draw it like that? Because, well, the compressor has 120, but remember the board, the low voltage side of the board's over here. So how much voltage should I have there?
Well,
I know this board update really screwed up my thing. Excuse me. Thank you. Let me just, oh, now it came back after I sneezed. Okay, so what does it say right there? 12 volts DC. So on the red plug, we can take our meter and stick it right in the back where these wires are. We're going to get 12 volts here. So I want you to connect this. When we put it all back together after we talk about the fridge, I want you to connect this. I want to do the 120 volts here and the 12 volts here. If I go to a customer's house and the compressor's not working, I have 120 here and I have 12 volts here, but my compressor don't work. What do I do? What?
Okay, pressure.
Check the compressor for what?
Oh, pressure. Check the pressure.
But the compressor's not running.
Well, sometimes.
They don't have a pressure switch. It's not like the AC or the ice machine where they have low pressure or high pressure cutouts. Refrigerators don't have that. So if there's no freon in a fridge, a compressor will run. So checking pressure is the last thing we want to do. But what about checking the actual compressor for ohms? Okay, if the windings ohm out good, and we have the two voltages and the compressor don't work, most likely the inverter board is bad. Can the compressor still be bad even though the resistance in the compressor checks good? Yes. Just because we have good resistance, the compressor is electromechanical. It has an electrical part, the motor, but it has a piston like a car, mechanical. Mechanical could be stuck, but you would feel the compressor get warm. It's trying to run, it's not running. Wouldn't the compressor get hot? So if your compressor is cold and your windings are good and you have proper pressure here, most likely your inverter is bad. Now, what could you do? You could order this and the compressor and see if I put this in and see if it gets it working. If not, I change the compressor and leave both on there anyways. But this is how you would know what is it the inverter or the compressor is the problem. All right, any questions on this? Okay, so there's a lot more. I'm not talking about everything in this wiring diagram today. I'm talking about just the control boards and the inverter board and the compressor. And let's go take a look at the refrigerator. I'll pause that for a second. We'll go out.
Good.
All right, remember I told you there's only two light switches here. And one for the left door and one for the right door. But notice there's 4 wires on there. So I don't have the diagram in front of me, but 2 of those wires are low voltage and the other 2 are AC volts. The auger motor, we look inside of this piece here, this is the auger. So when the motor turns, it pushes the ice this way and pushes the ice out the door. Okay, so these switches here not only turn off the motor, but a lot of times they will stop the water from coming out the door too. So that if you open the door, the water or the ice maker won't run. All right, so can you just put that on the table, this one, please? I'm not going to take this whole assembly out, but if you look at this wire right here that I got my finger on, that is the flex tray there, and this wire right here is the sensor on the bottom of that tray. So remember one said tray sensor? So if you let other people take a look real quick. Did you get it?
Yeah.
But if you guys look, it's this white wire right here, and it goes to the bottom of the tray. A lot of times that sensor falls off into the bucket, and now the ice maker doesn't know to drop the ice.
Ese cable es blanco ahí.
Okay, so that's one of the sensors. Now there's another sensor in here behind this compartment. That's the refrigerator sensor. It's down by the damper. So I'm not going to take this refrigerator completely apart now. When you guys do hands-on, you'll find these, and we'll take these out and clean them out. So there's one sensor here. There's one sensor there. And the other one I told you was on the main board. So that's 3 of them. The other 2 were in the freezer, right? So let's take a look here. So in the back here is an evaporator, and that's where the cooling is done on this unit. Okay, there's a damper that controls the air up into the refrigerator, and that evaporator has a sensor on it. Why do we have an evaporator sensor?
It sends frost buildup?
Usually for defrost, not necessarily to tell it to defrost, but when it goes into defrost, it controls the defrost heater. That's what tells the control board, hey, stop defrosting because it's so hot back there. Now, a lot of times you'll find a defrost thermostat, a mechanical one, that's usually in series with the heater, so that if the control board, let's say the sensor tells the board, hey, shut off, and the board, the relay doesn't shut it off, or something goes wrong with the sensor and the sensor is not telling the board the right temperature, then the defrost thermostat will turn the heater off anyways. Because even though the refrigerator is not going to cool, if it doesn't go back into cooling, it'll prevent that heater from being on and cooking everything and melting stuff back there. I've seen an Avanti refrigerator back in the 90s when I was working for BrandSmart that they were joking at me when I went into the shop and had a top freezer, and they're like, oh, open the freezer. So you grab the door and the whole refrigerator is moving. And they're laughing at me like, ah, ha, ha. So I grabbed the handle and I ripped it. And when I ripped it, this plastic liner in the freezer, it's a small top freezer, this liner melted to here because it went into defrost and the heater didn't shut off. So when I ripped it, I ripped this plastic off of the door. It was garbage anyways, but they were laughing at me, but then I laughed at them, ha ha ha, I got it open. So that was the evaporator one, but there's another sensor in there, it's called the freezer sensor. Let's take this out for a second. And let's see if we can find the freezer sensor. Now, if we look, I think it's on the right-hand side here. It could be behind this compartment too. Sometimes you'll find it in here. Sometimes you'll find it here. And the freezer sensor is what tells the refrigerator what is the temperature of the air inside the box, not the evaporator one. So the evaporator is for defrost. The freezer one is for the temperature of the freezer. So we have a sensor down here and a sensor up here telling the refrigerator what the temperatures are. So when you look at here and you see the two temperature readings, the freezer on the left is this freezer compartment, and the one on the right is the refrigerator compartment sensor. And those can be tested through diagnostics. You go into diagnostics and it says freezer sensor. It says 0 or 1. One of them is good and the other one is shorted or open. You have to look at the diagnostics to see what that is. I'm not going to tell you guys what it is. You have to figure it out. But when you go through diagnostics, it checks the sensors for you. So you don't have to tear the whole machine apart just to check the sensor. Now, if it comes up bad, do you just order the sensor or do you go there and test it? What do you do?
I would test it.
But why?
Or something that's wrong.
Yeah, what if the sensor is good,
Right.
but the wires that run from the sensor to the board, one of the wires got chewed up by a rat or got too hot and melted somewhere. So the sensor may be good, it's just the board can't read it, or the board says it's open or shorted. So just when you go into diagnostics and it tells you that failed the test, that doesn't mean stop what you're doing, order the part and come back. Because you'll order the part, you'll come back, you'll open the whole machine up, take all the shelves out, put a new sensor, put it all back together and plug it in, and you got the same problem. Okay? So a lot of times, all these things that I'm pointing at you, like the auger motor, you see this little piece way back here. That's the auger motor. The two little metal fingers. There's a motor back there. Now that's a geared motor. What I just did, you got to be very careful because on some of these, the motor mounts, you can see the screws coming through that are holding the motor in its place. You take your finger and go like this, and you get your finger caught between that auger and the screw, and it'll cut you. Like, you can't stop it from spinning. When you do this, that's a geared motor. You can't just stop it like that. So when you go like that and if your finger's in there, it's going to hurt you. Now, a lot of those augers, and I didn't really want to talk about auger, we were talking about control boards, are left-hand thread. So what do you think is tightening, is loosening, and so forth? There is a way to take it apart. Whenever you guys work on these machines and you open them up, call me and I'll show you how to take the auger off. Okay? So the idea behind the control board is those components here, the ice maker, the auger, and then there's another piece on the left right here. There's a little opening. Does anybody know what that is? That little piece back there. What does that little piece do? You can take your finger and hit it. That little square opening on the left-hand side in the bottom. Can you see it all the way to the left there? So go like this. That square opening on the left of all those little holes. What do you guys think that is? Well, what is it?
It changes state on what type of ice you want.
And what are the two types of ice we get?
Crush
and cube. So where's that ice bucket, Joseph? So if you look here, this lever is controlled by that solenoid.
Ese es switch.
No, it's mechanical.
Yeah.
Look here. You see how it's opening and closing? So right now it's closed. When I go like this, it's open. You see that? It's open now. When I go like this, it's closed. So right now, with it closed, it's crushed ice. It forces the ice between these little mechanical teeth, and it breaks it. It doesn't actually like it breaks it up in small pieces. But if I energize a solenoid, now it got an opening so a whole cube can fall out. Now sometimes if someone in the house uses a lot of crushed ice, and then another person comes up behind them and wants cubed ice, they're going to get some crushed ice because there's some here and there's some in the chute, and that's normal. If they complain about it, that's normal. Okay? So all of these components, the lights, the ice maker, the sensors, the damper, the fan motors, the compressor, they all run back to this board. And when you're doing the hands-on, use the diagram and try to figure out, okay, evaporator, fan motor. It's in the freezer, but where does it connect to the board? What two wires on this board is going to that fan motor? Check the wires, not the board. Unplug it, see which two cables is going to the fan, and check the fan from the board. I want to check the crushed cube solenoid. Can I do it from the board? Yeah. But if I don't get a reading, always go to the part and confirm that that part has failed. Now this goes underneath this refrigerator down in the bottom here to the front, and all the plugs plug in, and the wires are connected here. There's like a little plastic piece that's supposed to hold them down, and there's usually one screw here that goes up and hold it in place. I don't see the screw here. I think it just snaps into place, but it keeps it. I've gone to people's house where they changed the board, and the board's just sitting on the floor. The wires are plugged in, but you see these two pieces on the side? There's grooves like this in the refrigerator that hold it in place. Make sure that you mount it in the proper place when you're putting this back in the refrigerator. So this is the brain. These relays here, these little white boxes, are how the board tells compressor to run. Well, not necessarily the relays, because that's running off a low voltage signal, that 12 volts, but the auger motor, the water valves, when you call for water, the ice maker, all these relays here are sending power to these components in the refrigerator. So everything falls back to the board. So when we got an electronic controlled machine, we always want to go back to the board and test that component if we can. Now, not everything can be tested from the board. Not everything. But learn how to test from the board. And then if you don't get a reading, now you go to the part to confirm it. Okay, so this again is just the brain, where this one here is the motor. So this goes underneath. This is actually mounted right next to the compressor. So these two have that 12-volt wire. This thing plugs over here. And then this is how the two talk to each other from these two wires. Okay, now this one's always connected to power, and this one's connected to the compressor itself. So these are coming in, and this is going out. All right. Someone was talking to me yesterday or the other day about SYCF. What is that?
System communication failure.
So what are we talking about with system communication failure? What is that error?
It's communication failure between the board and another component. So
What was the other component? That's this one. If you see SYCF, that's system alert, like a system warning, communication error. So this board and this board don't talk to each other. So that means we got three control boards, right? We have an inverter board, a main control board, and then this one is how, like, you're playing a video game, you know, PS4, PS5 now, whichever is out now. I don't even know. 5 is the latest one now. I don't know. I can't keep up with them. But anyways, you have the PS4 sitting on the desk next to the TV. The TV connects to it, but how do you control it? You have the controller over here, and those buttons is the user interface. When you press buttons, it's like pressing buttons here. You're sending a signal from here to the main board, which is telling the machine what to do. Okay? But there are other SY errors. So when you guys are working on this machine, find out what those errors are. Well, there's one, SYEF. What do you guys think that is? Think about it. What would EF be? Do you know what it is?
Evaporator failure.
Evaporator what? Fan. Evaporator fan motor. So if the evaporator fan is not working, you might get an SYEF. So look at the service manual and learn what those codes are, because you don't know what the codes are. You go to a customer's house and it says that, and you're like, oh damn, what did that mean again? You know. Now, one last thing is there's something called Sabbath mode. Does anybody know what Sabbath mode is?
For the day of the Sabbath, when Jewish people can't work as hard, so the refrigerator isn't working.
Well, they're not supposed to do any work. Yeah. And it's usually, and don't get me wrong, because I'm not Jewish, so I don't know the true religion, but it's like Friday at sundown to Saturday night. Okay? So from that time is their Sabbath. Like Christians, Sunday is our day not to work, right? Supposed to work Monday through Saturday, and Sunday is the day we go to church and we observe our religion, where the Jewish religion is more on a Saturday, Friday night to Saturday. I give you a story. A customer not called me, but the neighbors below me were Jewish. And I came home, my girlfriend, and it's an older couple, and they're standing outside the car like this, the door's open, and they're standing there looking in the car like this. They're not touching anything, they're looking at the car. And I get out, my girlfriend, and we're parked right next to them. We start walking in the house. He said, excuse me. Yeah? Can you do me a favor? I said, yeah, what do you need? Can you take the keys out of my car? And if I came to you and say, hey, take the key out of my car, you're like, why? Is it stuck? And I look, and the keys are in the ignition, but he can't take it out because he got home and it was sundown. And taking the key out and all that is considered work. Just turning the light on. Yeah. So when you open up a refrigerator door, the light comes on, right? Yeah. You put it in Sabbath mode, and I want you to see, because you're going through these tests now, the lights aren't supposed to turn on. So you are not energized. Like when you go to the bathroom, you're not supposed to turn the light switch on. You go with a candle. When you want to eat, the stoves have Sabbath mode. Sabbath mode turns the oven on at like a warm setting, not a cooking setting, like 100, 150 degrees or whatever. So what they do is they prepare food before the Sabbath, and on the day of the Sabbath, they put it in the oven, and they program it for Sabbath mode. And I have a video on how to go into Sabbath mode and how to calibrate an oven. It's a very short video, 10-minute video. But it keeps the oven on, but they open the door, the light in the oven don't come on, and they're not turning it on and off. You say, yeah, but aren't they using? They're opening the door, but they're not technically doing work. Once the electricity starts running through and everything, that's what that is. So Sabbath mode may turn the lights off here, maybe not, but they press the buttons and nothing's going to change. The lights won't come on. It's just there keeping food cold so they can get cold food out of there. An oven, Sabbath mode, is the opposite, keeping the food warm. And then until they cut it off, it doesn't go off. It stays in the Sabbath mode until they keep it off. So that's how they have hot food throughout the day. So going to the unit, the control board controls everything inside these appliances, washer, dryer, refrigerator. It's the main, brain of the box. Everything runs back to the board. So remember that when you're troubleshooting an electronic machine, you see a part in the machine that's not working, say, hey, can I test that part? there's two tests from a board I could make. Let's just say that auger motor is not running. It's not pushing the ice out. Everything else is working but the auger motor. What two tests from the board can I make for that auger?
Resistance check.
I can do a resistance check, so I can unplug the plug that, and we can look at the diagram that tells you, oh, this motor goes to J5 or whatever. And if you look, these little plugs on the board here, if you can show these little plugs on the board here, they're the low voltage. Notice how these plugs are bigger and got the relays over here, because that's the 120 volt side. That's the high voltage. This is the low voltage. So my auger motor's got to be over here because the auger motor is 120 volts. But I can unplug it and ohm the motor out. But what other test could I do? I sort of gave a hint. Power. I could go to plug it back, and the same two wires, I could push like I want ice to come out and see if I have 120 here. If I have 120 on those same two wires, what does that mean? It doesn't mean the motor's bad. It means the control board's good because the control board is sending power. We still don't know if there's a broken wire, broken connection. We don't assume the motor's bad, but we know, hey, my problem is not my board. I've eliminated the board. When you go to a machine and you're not comfortable with troubleshooting it, you start testing things you know how to test and start eliminating those as possible problem. I mean, if I go to this refrigerator, it's not cooling, am I going to check a water valve? Am I going to check the ice maker? No. I know what components I need. Compressor, fan motors, defrost. Those are things I need for cooling. So I start testing the fan motor, the condenser fan motor, the evaporator fan motor. Or I just look and see if it's working. You have to eliminate. If you don't know, my problem is this circuit. I know this piece is the piece not working, and I just check that circuit. But if you go to a machine, and trust me, I do that a lot. You know, I don't do as much repairs as I used to back in the day, but I started from school, I went to work for Sears. Sears, 99% of their product was Whirlpool back in the 80s. Some were Frigidaire, some were GE and other manufacturers. But when I left Sears after 5 years, I went to go work for a company called BrandsMart. Well, BrandsMart sold Amana and Admiral and Maytag and all these others. I never saw them when I was working for, now Sears sells everybody, but I never saw those machines. So I had to figure out how to get inside the machine and how to troubleshoot the machine, but I wasn't familiar. It's like you going to the very first machine you ever worked on in here. You don't know where to begin or what to do on those machines. So you have to say, well, what can I test? What can I check? Does this piece have anything to do with my problem? Because troubleshooting begins with just start testing things. And oh, this piece is good. I press and I hear the motor running. That's good. Okay, let me check this. Let me check that. Because if that auger motor don't work, I can check the auger motor from here. If I don't have voltage coming off of my board going to my motor, what do I do? No. I don't have 120 from here going to that motor. What do I do? You what?
The line connection.
Go back to the very first thing we talked about today's lecture. Not necessarily power. I pointed it out, guys. Remember I told you there's 4 wires on here. 2 of them are for the board to go beep, 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 the door's open. But the other 2, I drew the circuit for you and said it goes where? To the auger motor. Could one of these switches be defective? Can I check those switches?
Yep.
But you see, everything has a connection. You're not going to look at that diagram and understand everything when you look at that diagram. We have to take a piece at a time and learn just that piece. Do the next one. Do the next one. and build the whole thing. Any questions on this, guys? Okay, so I'm gonna let you go back to work. I'm gonna have Paul William put this refrigerator back together, these boards and stuff. Once they have it back together, I'm gonna call you guys back again, and I wanna do the voltages on the inverter board and show you how to do that, okay? Now leave this board, connect all the wires, but don't stick it inside. Leave it out here connected so we can look at this board and the inverter board too, okay? But you're gonna have to put this inverter board back together. Well, we're not, yeah, we do have to put that together too. But we're going to put this back together and have these wires coming out through the openings where they're supposed to come out, okay? Just stop that for now and